Alright, we're going to look at the solving problems, exponential and logarithmic application. Your questions will be different than mine, but it'll be pretty much the same process. So let's go ahead and look at that. It gave us the equation that we're going to be using right here. Now we just need to know what we're plugging in where. So in this case, we can figure out our rate really easily because it's the percentage, but we have to change it to a decimal. So 4% is 0.04. If we look in this problem, how much they invest, that's always P, which stands for principal. So, and then if we look over here, this is going to be the amount that we're looking for, the amount that we are ending at. And then it says how many years, so that's going to be T, which is our unknown. So if we set this up as A equals P times 1 plus R to the power of T, we'll have 12,200 equals 400 times 1 plus our rate, which is 0.04 to the power of T. So now it's just doing some PEMDAS and doing some log problems. So we're going to start by dividing by 400. If we get that, we get 30.5 equals 1 plus 0.04 is 1.04 to the power of T. Now here, since we're trying to find the exponent, we have to set this up as a log problem instead. So it's going to be log with a base of 1.04 of T equals 30.5. Log. Oh, sorry. It's going to be log base 104 of 30.5 equals T. There we go. Now we can't on our calculator do a log with a base of 1.04, so we're going to have to change this around using the properties of logarithms. And so that's the change of base property, so we can do log of log base 10, so now we can do it on our calculator, of 30.5 over log base 10 of 1.04, and that will give us T. So you find each one separately and divide, and that will be your number for T, which you can just do on your calculator. Let's look at the next one. Okay, so this one is going to be exactly the same thing, so we won't do that. See if there's anything different. Okay. So now calculate the balance. Okay, good. So this is a little bit different. We have a different equation. A equals P times E to the power of RT. So you invest 3,400. That's going to be, that's going to be P. We have our rate here. So since it's a percentage, we need to change to a decimal. Move it over twice. 0.055. So P is taken care of. E is just a number, R is taken care of. Now it says calculate the balance, so that's A, of your account after 6 years, which is T. So if we set this up, we don't know what A is. That's the easiest thing to find out. So we got 3,400 times E to the power of 0.055 times 6. And now from here, you're just going to do a step-by-step problem in your calculator. 3,400. What we're going to do first is the exponent part. So you're going to multiply these two, which let's see what we get. 0.055 times 6 gives us 0.33. So in your calculator, you'll just type in, let's do this part first, e to the power of 0.33, and then you'll multiply that by 3,400. Let's see. That's going to be the same thing as before. Solve the equation for x. Okay. So it says raise each side of the equation as the power of the base of the log. Okay. So log 2x equals 9. We're going to now have 10 to the power of, in this case, log x equals 10 to the power of 0.51. Simplify. Okay, so let's see. Let's see. Okay, so this one, I'm not going to really set up the way that they did it. We're going to do it a slightly simpler way. So we're going to change this instead of a log to an exponential equation. So we're just going to rearrange. So if we have log x equals 0.51, we know this base here is 10. And so how we rearrange this to be an exponential equation is 10. So the base here is the big base here. And so we do 10 to the power of 0.51 equals x. So this is how we would set up going from a log equation to an exponential equation. And now you just plug this into your calculator, 10 to the power of 0.51. So if we do another example of that, let's say we have log of 3x equals 17. How we would set that up, we know there's a 10 here. We call this the base, and so then we're going to make it the base of our exponent, and then go to the other side of the equation, so 17 equals, and back to 3x. So it goes bam, 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 is how we would set that up. And then you just do it in your calculator. Same for that one. All right. Okay, this is going to be pretty much the same thing as the one we just did, but with e instead of 10. So if we have, and I like writing the log first, ln of x plus 9 equals 1. This is, ln is really log with the base of e, and then we get x plus 9 equals 1, so we're going to have e to the power of 1 equals x plus 9. So e to the power 1 is just e equals x plus 9, so we'll subtract 9 from both sides. So in your calculator, since e is a big decimal, we'll just do e minus 9, and that's what x is equal to. Same for that one. All right. Okay, so this is easy. We're just going to plug into r equals log x and solve. So the reading was 5.8 equals log x, and I like putting the log first when we do this. There's a base of 10, so we're going to rearrange it to be exponential, so 10 to the power of 5.8 equals x. You do that in your calculator and you're good to go.